Our all hands run about an hour long. Today is an hour and a half because we have so many exciting topics to tell you all about. So we are going to go over a little bit longer. We will try a little bit longer than the hour, not hour and a half. We will try our best to run through these as quickly as possible. So thank you in advance for your patience and for understanding. And then with that said, as I mentioned earlier, participation is highly, highly encouraged. Feel free to leave any questions, comments, concerns. If you're excited about something, if you want to know more about something, drop it in the chat or drop it in that link that my colleague Shreya dropped in the chat group as well. So now over to our agenda. Today, joining us, we have Andrea Volpini from WordLift. Andrea, thank you so much for being here. WordLift is one of the few platforms that's actually using AI for search automation. This is going to be a real live use case that you guys are going to get to hear. So we're super excited to have Andrea telling you more about what they're doing and they're building out with Jina. We also have Florian Hoenicke with us. He is the head of Jina NOW, and he is going to be telling you all more about Jina NOW and the different services that it offers. And then after each presentation, we will have some time for questions, but if you have questions as they're presenting and they interject, again, please don't hesitate to drop those in there. Myself and my colleagues will try our best to monitor and ask our presenters as those questions come up. All right, now with that said, and without any further ado, I would love to kick it over to Andrea.
All right, so I'll share my screen. I hope everyone can see it.
Yes.
Good. Thanks, April. Thanks, Florian and the Jina AI team for inviting me here today. And let's get started. It's interactive, so stop me anytime or raise a question, and I would be happy to go over. So this session is going to be about search engine optimization, which also covers some structured data automation. Today, optimizing a website also requires to generate content using natural language generation. So I'm the CEO of this company called WordLift. We automate SEO. We build knowledge graphs. And that's pretty much my draft presentation. This is a fake Picasso because I started to do paintings of famous artists in the last 6-7 months. I've been playing with this quite some times. Now Jina is making it very easy for me to do that. So every day I do a new one, and we'll try to understand a little bit how things work, what I learned with this personal experiment, and also what it has to do with SEO and with Jina. So a lot of the images that we see these days are coming out of systems like DALL-E 2 or DALL-E 1, or there are all sorts of different models that we can use for converting a plain text into images, and these systems can maintain, some level of semantic consistency within the images. They do still struggle to be 100% similar to what a human being would do, but they can create amazing images and create variation of the same images, and also allow us to edit images. But how do they work? Because of course, when we have to optimize a website for search engine, we have to understand how things work. So what are diffusion models? And so this is a very basic description, but diffusion models are generative models, and the working principle, it's quite simple. They take a piece of data, in this case an image, and we'll start with an artwork from Giotto, and then they will start adding noise in a sequence, in a Markov chain, if you like, until the image is no longer recognizable and it's all noise. And then they will do exactly the reverse process, though. They will try to reconstruct the image and back to the original forms by denoising. So diffusion models works pretty much like autoencoders, for those of you that are familiar with autoencoders in NLP. And that means that they transform input data, like an image, into a representation, into embeddings. And then they can reproduce the original data from these embedding information from these latent space, it's called. So they work by, as we saw, adding noise and subtracting noise and then predicting what the original input was. So this is the entry into New York by my fake interpretation of Giotto. The very famous painting is the entry into Jerusalem. So behind these diffusion models, before that, we have a contrastive learning image pre-training model released by OpenAI as open source and called CLIP. And CLIP has been designed in order to create, to make converge the embeddings of a description of an image with the embeddings of the image. And during the training, the two networks will try to adjust the weights so that the similar image and the similar description will converge. And everything that, and of course, within the same batch, the description that doesn't match will diverge, will be kind of sent in a different space. This means that we can use CLIP for, image classification or so-called zero-shot classification. We can quickly convert both text and image. And then at the end, we can, do comparison like this, where I have an image of two zebras, and then I have a, descriptor, a caption like a photorealistic image of a horse, which is not totally right. And then we kind of get, using CLIP, a percentage of, match between the two, between the image and the description. And that's kind of the way in which we can convey and send information to the system, and then it will create a latent space, and then from this latent space, using a diffusion model, we'll generate the image. I can see there are some questions, but I will let April do the show and stop me. So prompt engineering, it's what allows us to create these images, but also we can use prompt, so these strings of text in order to control the generation of content coming out of models like Google T5 or OpenAI's GPT-3. And of course, the way in which we can instruct CLIP to create images, it depends highly on its training data. And CLIP, like most of these contrastive models, have been trained on a vast amount of information coming from the open web. And that means that we can use markers like the website where these images have been taken from, in order to instruct the model to produce an image that maybe looks like what we would find on DeviantArt. Or maybe we can use something like, I don't know, AK3D, and or something like, I don't know, CryEngine. And so the same image will be presented in different way based on, for instance, the type of website. Now, of course, as most of these models, there is a catch, and there is something that we need to very carefully consider, that these models are biased. And there's not much that we know about the training data either, because of course it's a vast amount of collected data comprising both images and description. But of course, as you can see here with this very simple experiment, we can see that a man will resonate more close to the concept of human being than, for instance, an Asian woman. And so, and this is kind of embedded into the system, and we have to be aware, because we have to then control it. We don't want to create a mess with these AI systems. CLIP is also full of stereotypes, and quite interesting. The same stereotypes, we will find them in most cases also in Google image search. And so if I go and look for a builder, the default behavior would be that we'll find white passing and Western type of individuals, and the same would apply if I would run a query like a flight attendant. Most probably will look like a female, and things like that. I mean, there's a lot of biases in the data that we process. in SEO, we have to be even more aware, because on one side, we want to understand how the search engine works, but on the other hand, we want to also create content that doesn't, offend people or create issues. So yeah, we have these stereotypes, and these are part of the risk and the limitation. I've added the link where you can read more about how to use these models. Why we came up with diffusion models? I mean, we already have, guns that were quite powerful, and we were already able to draw illustration of baby daikon radish in a tutu walking a dog. So we could do already a lot of fancy things. So why we wanted to move into, diffusion models? This is, by the way, DALL-E version 1, which wasn't using a diffusion model. So one of the issues with these models is that they lacked realism, and we want high fidelity and realism, and that's what we're getting with diffusion models. These are some of the paintings out of famous painters that I am generating with my collection. I have over 155 different paintings. Every day it's a new painter, and I'm generating these. Then I project it in the office, on the street, and we'll do an exhibition, hopefully in Venice sometime soon. But what is interesting is why I'm doing these every day, and what I'm learning from these. I mean, there are a lot of consideration that we need to make in order to understand how a system will create embeddings, what is this latent space that generates the image, and there are other aspects. And why is it important for SEO? Because of course, one aspect is that as I'm doing this, I'm learning how to speak, how to craft my prompt in a specific way, and this allows me also to think the way in which I can instruct, for instance, GPT-3 for creating a text. But also it helps me understand how I can help Google be trained with things that it doesn't know. So here is my cousin. He's a painter, and he lives and works in Rome, like me. And CLIP doesn't know him. And by the way, Google doesn't know him either. So if I go in with Google Lens and I try to take a photo of Giulio's painting, it will find a match, resemblance with Piero della Francesca and other painters from the 1400s, and that's totally right. That's Giulio's style, but it doesn't know Giulio. So I started to work and see how I could train the system to produce a fake Giulio Rigoni. So I had his website with WordLift, which means that I can create a knowledge graph with all the images that Giulio has made, and I can run a GraphQL query on the knowledge graph and get a batch of paintings from Giulio's site, and I can use this painting as a prompt into CLIP. So CLIP will encode the paintings, or the batch of paintings taken from Giulio's site through the knowledge graph that WordLift creates, and then we'll train the model, and we'll instruct from the latent space of what it's grasping out of the images, the diffusion model to generate a fake Giulio Rigoni, like I do with the others. And so you see above that, it's definitely better, the real one, but you can see below that I'm able to create something that resembles or gets closer to the paintings of Giulio. And here I've made a collab using Jina AI that you can play with, that allows you to do basically two things. We can quickly create a doc array in Jina for all the fake paintings that I have generated, and then we can immediately use Jina to find, for instance, a painting about peace by Picasso. And quite interesting, I'm immediately encoding all the fake images, and then I'm able to make a query, and then I'm able to get the fake Picasso that have been generated. And that's quite powerful because it's a few lines of code, and I was able to, index my collection of fake paintings and immediately run a query there. And you can run, of course, multiple queries and be able to detect. So it's kind of, a reverse engineering of how I made the fake using Jina to search the fake using a text string. What if I use an image? So then I started to kind of throw into a painting of Giulio. And as you can see here, the first match is actually the fake Giulio Rigoni. So again, I was able to kind of reverse engineer the mechanism that I use for generating the fake using Jina to see, how things work behind the scene. And also how a system like Google Lens would work when recognizing, for instance, a painting that hasn't seen before. So long story short, to summarize, we went through already a lot of concepts, but Google uses machine learning and deep learning. And of course, it needs a lot of training data in order to get better and to know things that it didn't know before. And SEO today, it's really about building this training data. And that's why WordLift creates Knowledge Graph, because we can structure the metadata that then something like a search engine, whether you build it with Jina AI or Google builds it with its own machinery, can use it and be trained on content that hasn't been seen before. So this is kind of, why it's so important to understand how things work for neural search, because that's exactly how we want to, instruct Google to understand more about our content and product and services. So we do all of these. Yeah.
Andrea, before you move on, just jumping back real quickly to your topic when you're talking about biases. So we do have a question here that asks, so what are some of the steps that engineers can take to eliminate the biases in CLIP and in SEO processing?
So let's look at what we do. Okay, what we do when we generate a piece of content right now. Okay, so right now we are mastering the prompt engineering, because, for instance, we're generating product description at scale. And we are generating intro for categories on e-commerce website at scale. Now, what do we do is to create a flow that once the content has been generated, will validate the generated content against data in the knowledge graph. So if I am describing a pair of, let's say, sunglasses with red lenses, then GPT-3 will generate the description, and then we will have another procedure that will extract what has been mentioned by the generated text, and it will check it against the ground truth, which is the data in the graph that says that that piece of that pair of sunglasses at red lenses. And if it doesn't, it will just discharge and ask GPT-3 to generate again. So one thing that you can do is filter the output of whatever you're generating. The other thing that you can do, of course, is kind of unbiasing data. And that means that, of course, you can let the system learn in a more equal form and kind of distribute and analyze the data that you're using for training. This is an option only if you are fine-tuning something like CLIP, because of course CLIP as it is, it's full of biases. So the only way that you can do to control it is kind of filtering the output at the end. But if you are retraining CLIP or fine-tuning CLIP, then you can kind of look at the composition of your data and make sure that it's balanced and fair.
Great, thank you for that.
Good. Right, so we saw, what we can do and what we do in order to extract Google and make it learn something new, like the paintings of my cousin or whatever you wanna teach it. But do we do these kind of extensive curation of metadata for Google only? Is it just about training Google? The fact is that whatever data we're throwing to a search engine, we're not just doing it for Google, because we also want to use it on our own AI systems. And we are experimenting these with Jina in several areas. So you might have noticed by using Google that a lot of the search intents that you might experiment with are full of frequently asked questions. And now, in some cases, you might get a panel with, for instance, QA pages coming from sites like Quora or Stock Exchange, where you have, one question and multiple answers. And now Google is also throwing into the results specific visualization for flashcards and educational Q&A. These are other boxes that allows user to kind of understand more the topic and refine the query. And of course, same applies to how-to content that also get a specific rich result in Google. So there is a kind of, I call it, I quote Jenny Eel, who is a very valuable SEO in the US, and then she kind of started to mention the rise of the question graph. So a knowledge graph in Google that it's full of question and answers, and these are kind of the different visualization that you get of these various Q&As, whether it's an FAQ, as you can see here in the first image, or it's a QA page like from Quora or Stock Exchange, or it's a flashcard. These are, just about recently introduced. We still don't know how they will appear, or how to. These are all kind of rich results that are coming into Google. And in order to get these features, we have to structure the content in such a way that Google is trained. Okay. And so we do this with structured data, but now that we have also this wealth of structured content and structured data that characterize, for instance, an how-to or an FAQ or a Q&A, what can we do with it? We can build chatbot, and that's what we are starting to do using Jina AI. And why chatbots? Of course, chatbots are good for providing support. Chatbots are good because they can help us in improving the customer journey on our website. And of course, there is an explosion of conversational user interfaces. So what are we doing with data that we are crafting for getting the features on Google, but now that we have it, we can reuse it, okay? So the whole point is that if I do something for SEO to get more traffic for Google, this data, it's precious, and I can use it for training my own AI, like we do with Jina. So we use knowledge graph just because they are, the simplest and most effective way to manage metadata on scale. And this metadata is consumed by Google, but we can also use it for, building a chatbot like the one that we're creating now with the Docs Q&A of Jina AI. And that's you can see it already on our docs, on our documentation, which has been built using Read the Docs, an open source framework. And now we are about to release a new version of these with the Jina AI teams that will not only take into account what we have in the docs, but will also index the FAQ content that we publish on our blog for Google. So the same data that we pass to the search engine, we can actually use it to train our own chatbot in order to create a better user experience for our users. And here you see another example where we have used the same FAQ data that we are using for doing SEO for building a chatbot inside one of our clients' platform. And this is one of the implementation where we can actually see the visualization of the results from the Jina documentation itself. And so the same data that I'm using for SEO, I'm using for nurturing the question graph of Google, is the same data that we are using for the chatbot. And of course, I mean, here you see kind of one of the first prototypes where we have this knowledge graph. We get the Q&A data from the knowledge graph, and now maybe also the open domain questions from the article, and we are able to create a conversational user experience. And I'm almost at the end of my session, and so I'm happy to conclude with one new experiment that I made just last week using Jina NOW. And I will let Florian explain what Jina NOW is, but basically my experiment is about creating a related search widget on an e-commerce website. A related search widget is something that allows a user to find a related category. So let's say that you are in a category where you're looking at sports shoes, and the related widget, it's that user experience component that will help the user jump, let's say, on the cycling gear or cycling shoes, or whatever related categories you have on your e-commerce website. This is pivotal in SEO because I can create internal links, and I can distribute the link juice, as it's called. So the ability for the search engine to discover connected pages with meaningful links. And also I can instruct the search engine by looking at the label of the anchor text for this link. So this is a super powerful mechanism for SEO. And rather than doing this manually, I have I've been using NOW for a text search. So I've indexed all the categories that we had on the Fila website. And I have indexed other textual element on the page that I crawled. And then using the sentence transformer, I started to connect things and generate the related categories for each one of the category of this e-commerce website. I've documented these in a blog post. You will find the link in the presentation. There is a collab for you to play. Yesterday we had some issues with the Jina hub, so I created also the version that you can run directly in Collab, following some of the examples that the team has shared with me. And so this workflow for creating links is as simple as extracting textual element from e-commerce pages, and then using the sentence transformer to find what is similar, and then creating a JSON that has the related links that then you can kind of bring into the knowledge graph or bring into the content management system, and then kind of display this additional set of links on the category page. And so these are kind of examples of how we are using Jina. I keep on doing a lot of these examples to help people familiarize with the concept of automating SEO. And the reason I started to use Jina is that, of course, we need frameworks that makes things easy because we have to focus on the SEO side of things. And we need frameworks that allow us to distribute the load, because of course, if you're running, something like a transformer right on your machine, it's not going to scale, and it's not going to allow you to run, let's say, something like a related search widget on thousands of category pages. It will collapse. But since I'm using Jina, I can distribute the load across multiple machines. I can define an architecture where I can decide where to run what. And that's the reason why we are investing on Jina and looking at new stuff and trying to leverage on it and bring it into our suite of solutions and products. And that's all I have for you today.
Perfect. Amazing, Andrea. Thank you so much. Really appreciate that. That was very insightful. So with that said, we've got a few minutes here. Does anyone have any questions? I know we had the one pop up in the app, but anything else? Henning says, great. They like the presentation. Any questions? Got a couple minutes. Oh, you got a fantastico. Okay.
Cool. I see noise here. Noise is actually one that kind of made me think of, how can I cluster queries and why it's taking so long if I use a sentence transformer. And that's why I think yesterday I kind of set up this workflow with Jina to analyze queries on scale. One of the things that we have to remember with when we use deep learning is that things are slow unless you distribute the load and you increase the computing power. There's no alternative there.
Yep.
Creating an image or generating a piece of text or extracting features from an image or creating the embeddings even on short pieces of text like Google search queries takes a significant amount of computing power. So if we have an infrastructure that scales, then we can reduce the time. And if we imagine how short it is the time for running WorkJina with German language. I mean, most of the team in Jina is actually from Germany, so yes, they do. But in general, I think when we look at text data, and the beauty of Jina is that you choose the model that you want. And I mean, I use the sentence transformer because there is a wealth of different models that are trained on different languages, and whether you need German or you need Italian or you need a pure multilingual. Yesterday, we were looking at an example where we have a website in multiple language. So the query that we intercept goes from, Italian to English to Japanese to Korean, and using a multilingual model from the sentence transformer library, we are able now to cluster, regardless of the language, these queries. So that's the beauty of using something like Jina and transformers, that they can work multilingual. Perfect.
Yeah, we have a question here from Charlie. They were able to join the beginning of the presentation. Yes, this is being recorded. We will post it to our YouTube channel later, and it'll be available for your viewing pleasure.
I can see a bunch of friends here. It's like a party.
Fabulous. All right. Well, any other closing remarks or plugs, or you want to let other people know, like, where's WordLift going to be? Anything you want to leave out there for your closing remarks?
Yeah, it's trying to cluster queries with just search terms, a waste of time. That's a very, very tough question. Now, there is enough context on most of the queries, I would say. So how does the clustering work? Let me see if I have something that I can share here. So how does the clustering work? Basically, we are using an existing pre-trained model, and so we leverage on what is called transfer learning. So the model has been trained on a huge amount of textual data, and it looks within the same context window of the relationship between the different terms. So if the queries are generic enough, it would do an amazing work in terms of clustering similar terms. Generating the embeddings, of course, it's an art, because if I need to dive into a specific domain, I might need to fine-tune my model and be able to detect, the differences between, let's say, one product and another. And this can be done whether it's a text or an image. And I don't see the need for fine-tuning models for analyzing search queries. In most cases, there is enough context. And if I'm looking for, I don't know, what was it today? We were looking at green urbanism, and the system was able to connect it with the searches related to sustainability. And so green urbanism and sustainability are far apart if you just analyze the terms in terms of keyword. But if you plug in the meanings with the embeddings, then you will find that the system is capable of clustering green urbanism with sustainability. In some cases, this doesn't work well enough for your system. So I would say that with text, 90% of the cases, you should be fine with a pre-trained model. With images, it gets a little bit more complicated. The other day, we were trying to classify sunglasses by looking at the nose pads, the presence of the nose pads. CLIP isn't trained enough on nose pads, and we will need to fine tune it to detect the specific features of a sunglass. So depending on the knowledge domain, you might need to do, a fine tuning. And here, Jina is something cool that I haven't worked enough, which is called fine tuner. So I will let Florian bring these forward.
All right, and we have just 2 more quick questions for you. One being, have you ever tried Jina AI for content websites?
For content website? Yeah, definitely. We're actually building a search engine for our own website with Jina, and we have used it in another occasion, and I think now with Now, Jina is adding the support for a text-to-text search, which I don't know if it's already available. I mean, I'm using it, but it should be available soon.
No, you have like a special pre-release version.
Okay. So,
but will be released in the upcoming week.
Yeah.
Of course, like our users working closely with us get, of course, like content earlier a bit and be treated better. So come work with us.
Yeah. Perfect. All right. And then last question here for you. So this person is always associated WordLift with structured data and KG. Do you see yourselves moving more into a semantic SEO and NLP models?
Well, I think that what we do is kind of a multi-layer approach. So we usually, when we approach an SEO project, an SEO automation project, we start by building the knowledge graph. Because if we have semantically rich data, we can do a lot of things. One of the first things that we do is improve the structured data and get value out of that. And then the other things that we do, we start fine-tuning models for generating text and for validating text, because that allows WordLift to create content on scale, at least for small snippet of text. And then what we're working on with Jina is to use this data in the graph to build search experiences, whether it's an e-commerce website, whether we need to create internal links or recommend a similar article in a publisher scenario. So I think that WordLift kind of tends to cover various areas of SEO automation, but we start definitely from creating a knowledge graph. Without semantically rich data, it's hard to work with AI in general.
Got it. Great. Well, again, thank you so much, Andrea. I appreciate it. And with that said, I am going to kick it over to Florian to start a discussion about SEOs and what they can do with deep learning in various areas. Over to you, Florian.
Okay, cool. Yeah. It's a pleasure talking to you, Andrea. We didn't have the opportunity in the last month or something talk a bit more closely, so that is cool. So like what I would be interested in getting your opinion is, do you think like the search in this traditional way, like you insert some text phrase and then get your results, that this is like the optimum where everything should diverge to? Or is search more like multi-stage, what we see, for instance, with Google Images, where you first search for these images, enter a text query, get some responses, and then you click on one of these images to get then similar images shown. Like, can this principle be applied to like everything, like guiding the user a bit more to the search? Because at the beginning they might not even know what to type in. What do you think about this?
Yeah, I mean, we look at the evolution of search engine quite closely. That's the job that an SEO would do. Is we constantly look at the major search engine to see how they work. And of course, one of the things that has changed dramatically is that search is now driven by concepts rather than keywords. And the reason Google uses concepts or Bing uses concepts is that with a concept, I can create a journey for the searcher. So I can help someone find what it's looking for in a multiple step. And it's also another important tendency that we've been seeing over the last 2 years at least, is that we are seeing that search is kind of leaving behind the paradigm of crawling and indexing in favor of creating a large web scale language model where I can actually ask a question and get an answer, which is then, part of the search experience. And that's why, we see that Google is enticing and supporting the growth of these Q&A type of data, because as it gets trained with Q&A, then it can drive the experience of the searcher with, multiple steps. So absolutely. Multiple steps and entities, I think are kind of the pivotal elements.
Okay, cool. Thanks. And something else where you, I guess you might have a lot of expertise is like, there's currently this another paradigm come up that search engines maintain a session. So for instance, everyone can try this also out, like on Google, when you insert or search for Python and then some query like how can I lowercase a string or something. And then in the future, when you type in how can I uppercase a string, then it already recommends you Python because it maintains some session information. They might do this for some reason because they get better search results for users. How crucial do you think is this personalization in that sense of session managing?
It's an essential part, because of course, as I was saying, search is becoming more conversational. And in order to maintain a conversation, I need to know the context. What Google is strong at, it's knowing the context of the user, and the context is made of hundreds of factors, whether you are connecting from a mobile device on a Wi-Fi network or on a G5 network, or whether you're using that browser or that device. These are elements of the context that the Google will leverage on in order to disambiguate the terms and provide you with the best answers. The same applies, of course, to the session data, and it's quite crucial. Of course, it's also one of the reasons why we see a lot of other players bringing the value of protecting data privacy. And then, of course, you can also use Google with proxies that will not let Google capture that data. But is that an important features for the evolution of search? I would say absolutely yes, especially because we want to converse with the user. So it's not just about providing results; it's about creating a dialogue with the user, and then we want to help the user find something that in a serendipitous way. And serendipity has to do with understanding the context again, and the context is also the session. So yes, it's something that I don't know what priority should have in your roadmap, but it should be there at some point.
Okay, cool. Yeah, I agree. Like this is like the top % you can get out of it when you already have very good search results. I guess, but yeah, will be necessary. And then another thing, so in your talk, you talked about the generation of images and of text. This year or like some years ago, it was text generation. Now it's image generation. The next will be maybe video, but then everything else, right? Is it like, do you think there will be like a boundary coming soon, or do you think also products will be fully generated like in the future? Would be like your ultimate way of customization, or do you think this will not happen?
No, computers are not sentient being. That's a first statement that these days we have to make after the case of the Googler that has been saying that a chatbot is sentient. No, so whether but yeah, content generation at scale, it's happening, and there's no, I mean, there's no question about it. But how do we make it happen? I think that's the most important question that we need to ask ourselves. And that's why I always keep, like, you know, the slides where I talk about the biases, or I make examples of things that don't work with these systems. Because of course, generating content at scale, it's an option, but the only way in which it can work, also in SEO terms, I mean, is by infusing human knowledge into it. And there are different ways in which you can infuse human knowledge into, let's say, a text generator or an image generator. It's by training. And so as we're working now with different brands on generating content, it's not that we are planning to replace the humans, quite the opposite. We are working in tandem with the human to create a superhuman that allows them, for instance, to personalize a piece of text in multiple contexts without having the need of rewriting the personalization. Because if I have to write a product description for a variant product, which is a product that has some characteristics that are similar to the main product, but some other characteristics that are different, and I have to write something unique for every variant product with an editorial team, it would be impossible, right? But if I train the system with the same, content that they would produce, and I would follow the same rules that they will produce, and I will work with them in order to create the AI that fits their content guidelines, then I'm bringing them the power to generate content that they would have no other option to generate. So how do we do it? What is the intention that we have? Is the intention to create crappy content at scale, or is the intention to scaling quality and preserving, the same value that content piece should have? I mean, that's where we're working on.
So that means like this job of the content creator would change a bit, because they get additional tools to create their content, but they would still be the ones curating.
They are the directors of they are orchestrating the entire process. And the first thing that we do when we work with teams is train them in understanding how the system would work and why we're getting these results. And what's in the sample that it's bringing the biases, and what doesn't work. And what is interesting is that in most cases, at least with our client, yeah, I mean, I'm very proud of the fact that we have, top organization that are working with us on these. They are ambitious. They don't want to just replicate what they do. They want to do something better, because they know that they are combining their own unique expertise with the ability of a machine to learn at scale their expertise and to replicate it. So just to give you an example, we've been able to create unique product description for one of the most iconic US brands for sunglasses. And it would be impossible for the team to do the work that we have done with them and with AI. And we have generated additional traffic for creating 500,000 of additional revenues, potentially, using the system. But again, it's not that we are kind of removing the human, quite the opposite. We are empowering the human by train on how to train a system. And then we are using, whatever indication we get to guard the quality that we generate. And the same applies to Google. I mean, Google will stop being Google if spam will go beyond a certain threshold. If the quality of the result in Google will go down, their business model will collapse. Google cannot afford to have low quality content automatically generated. But Google generates a lot of content automatically for its own knowledge panels, for instance, and there's nothing wrong with that. I mean, as long as quality is preserved and the ability of the humans to provide the direction of what content needs to be produced, there's nothing wrong with generating content, whether it's a text or an image.
Cool. Yeah, I'm very excited what the content will look like, what humans are able to create using the
It
new
looks
tool.
like the content that a human would have written, but it scales to levels where a single human would not scale. It's like for an editor, for a writer, a content writer, to have a kind of an army of other content writers that just write like him in all different contexts, and therefore you can afford to say, hey, these category intro text for my e-commerce website, I'm gonna make a version for the summer and a version for Christmas, and then I'm gonna tweak it slightly because in SEO it would rank better if I use this term rather than this other term. But it's still me, it's still my writing. It's still my editorial kind of way of writing content.
Yeah, sometimes I think we did not fully discover every possibility, and so sometimes we see new trends are setting up, and okay, maybe with a different topic, but for instance, the music generation, I would be very curious in what humans could, or music humans could generate using AI. Maybe some sounds or some music we've never heard, like which doesn't sound familiar to us. And I think the same for products or inventions. And yeah.
Yeah, I mean, the image, I think, are quite evocative in that sense that you can see, things that are hard to conceive for a human. Because of course there is this kind of in the so-called latent space, there is this mix of human knowledge. It also makes us think a little bit of how wrong is the idea that we have of knowledge, because we always had this idea that you're knowledgeable if you know things and you can repeat well facts. And now we have these machines that are quite good at repeating facts, but still they're not sentient. There's nothing like sentience in a machine that just repeats even if it does it in a fluent English or whatever language. But yeah, so we kind of have to think also how we frame the concept of knowledge and intelligence, and kind of revise that a little bit, I think.
Cool, thanks. Are there some more questions from the audience?
Copyright.
Panel discussion.
Copyright is big. It's a huge issue. I can see that someone mentioned copyright. So I'm doing these fake paintings, and I always wonder. One of the questions that I have is like, so I've done one thing with a very famous Chinese artist called Ai Weiwei, and I was lucky enough to have a friend of a friend that showed a piece that I did by kind of mocking his work, and he said thank you, and he was happy about it. My experiment of doing fake. My cousin was less excited about my ability of producing his fake art. But one thing that I realized is that there might be an artist that doesn't want to be used as a reference for an image. So we need to bring the ability into the system, for instance, to opt out any image that an artist would have produced. And then we're so far behind this the ability to do so. Right now, there's no option to opting out, let's say, of CLIP and say, well, you should not be able to do Picasso type of work, or you should not be able to do any Kandinsky type of work because you're not allowed to. And if you think about it, that's one of the things that we should be able to do. I mean, we would need to leave artists and creators the ability to opt out of systems like that, and say, hey, sorry, you can't use my data. That's my data. You cannot train your system on whatever, and kind of let anyone create something similar to my art like I'm doing. So this is one of the issues that we need to. Attribution. That's a big question. How do we attribute the traffic that we generate? It's a lot of work. It's a lot of hard work. But typically we use casual impact analysis if there is enough traffic, and we create a control and a variant group. in order to measure the actual impact of the structured link data that WordLift generates. So yeah, causal impact analysis and control and variant group are one of the ways in which we can kind of get the attribution of the traffic, because for us it's vital that we say, and we bring back to the client, we say, hey, that's our traffic. We work with clients, and most of the client have their own way of kind of testing and validating the results. But yeah, in most cases, it's about creating control and variant groups. Yeah, that's a super important topic, because it's not trivial. You need to project what the website would have made, regardless of the intervention. So you can see when you have a control and a variant, you can also make the projection of with a kind of a time series and see what would have happened without the treatment and what has happened because of the treatment. And then you just look at the delta and try to get a net percentage of increase or decrease. We run a lot of these experiments because we constantly have to iterate on the type of structured data. And we might decide that, for instance, we add links inside the FAQ answers, and then we have to see if adding the links will deal with the effects of the markup or not. And so we have to constantly test, or adding shipping details on an e-commerce website, is it good or bad? It depends, because on some site maybe we have very bad shipping terms, and so it's better not to provide the information to Google. When the shipping terms are decent enough, then what we see is that Google will have the confidence to display the product on queries that have to do with shipping, like where can I find these in 3 days, or free shipping type of queries, product and then free shipping. You will get traffic if you provide free shipping, and you provide the structured data for free shipping. So we have to run a lot of experiments for these.
Cool. Yeah. Thanks a lot for attending this small panel session. I really value all your deep experience in the industry. And that's also why we get most of our feature requests from WordLift, basically. And we can really rely on, this is not something just you need for your personal case, but it's just a lot of learnings from the whole industry, because you work with a lot of clients already, and you have this collected knowledge.
Yep.
And yeah, cool. So
it's fun to work together, because you're also very fast in taking the ideas and bring it to production. I mean, these 2 days we ran already kind of 2 demos at once, and there was someone from our team that was already using a Jina flow this morning for a presentation. So it's fun. It's really interesting.
That's true. Cool. Then I guess we can now go to the next part of the Jina NOW presentation. So before you already mentioned it a bit, you did a text-to-text search, which is currently not available, but stay tuned, 1 week. But a lot of other search modalities and search directions are possible. And first of all, thanks to all the remaining attendees, that you still are with us. And now I have something to present to you. Let me quickly share my screen. So before doing anything, I just give you some example. So here in this case, we inspired by WordLift, we indexed a session data set. So it's not the exact data set from WordLift, but an open source data set we used, the deep fashion data set. You might know it already. And so what we could do is taking one of these phrases here and find then related images. So it's a text to image search. Blue shirt woman, white royale. And these are the results you get. But of course, like these are just some examples you run. You can also come up with something like, I don't know, like beige dress for barbecue. And then you get your dress for the barbecue. And yeah, you could even like write something which is clearly not in the data set. So like, what is it? SpongeBob costume. Hey, what would you expect? Like, if it's not there, then it's not there. It should show any results, but it takes what is closest to that one. So it just shows something yellow. And you could even think like, okay, you could make a costume out of this if you put some points here, and then you can buy this and build your own SpongeBob costume. But at least the closest thing it's matching. And that's what semantic search is. So like in traditional search, whenever something is not matching very accurate, then you don't get good results at all. But in semantic search, it's like more fuzzy, and you get more semantic similar results, even if this doesn't exist. And yeah, we have a lot of other cases. For instance, here is an NFT data set indexed, and you already see the pattern. Like it looks very similar, but a different data set is indexed. And this is what you can do with Jina NOW. You give your own data set and then index it using Jina NOW, just without using our framework, because it can be very complicated to learn in the beginning. You have to at least read all the documentation. But if you would like to get started right away, you can use this and host your own search case. And for this NFT data set, for instance, here we have a work waste board, unshaven, sunglass, orange, black monkey, and then for whatever, it gives the closest matching results for this NFT data set. So something here with a cigar, and then even this is not a cigar, but something in the mouth, and then the model tries to, even if this doesn't exist. And we could also think about the other way around. In this case, we search with an image and try to find text. And here one colleague of us, Joshka, he indexed the rock lyrics data set, just from some bands, some rock lyrics. And if we just search, or let's do something so that it actually it's also raises. Then what we get here is he changed the hand live, everything works out okay. It's like giving something positive. Something here is something recognizing something with thumbs. So yeah, and if we do something else, for instance, this, so today I was at the buzzwords, so maybe it picks up the hat and gives related lyrics to that one. Yeah.
So Florian, we're getting a few questions in here. So I'll start with the top one. So we have a question on where are the images being pulled from?
That's a good one, yeah. So in the previous case, right? Like for instance, that one and that one. So I will show you in a minute on how I set this up. Right? You can just create your own document array if you're a bit familiar with Jina, and then run it in Jina NOW. But you can also just have a local folder. So once I indexed some images from my previous vacation, and then I could just write some searches. Where is a image of a beach, or like the hotel room or something, and then it gives me exactly these ones. So images can be, like in this case, like ones we host just for you to experiment around. It can also be your own one, and your own lyrics or your own text and whatever. And yeah, in this case, it clearly saw the head and put a lot of results, including that one. And at the beginning, I thought this is just for the lol, so we built this case because it's funny. But today on the conference, I got feedback from one potential client. He was saying they use this to get tags for images. And if you don't have a finite set of tags, but more phrases, and then they have a lot of these phrases, and they can, using this, just take the top K results for images and therefore have tags for their image content, which is quite cool. And then before I show you the like how you set it up on your own, I would just like to show you also that in this case, it's like some custom data type, and you know, some data set like this home office data set. This was indexed, containing a lot of anything related to home. Of course, you can upload an image, but it's much more fun with the webcam. And so I found this very funny. I tried this out before, and then this showed as results. So model somehow knows that I normally wear glasses, but not today. I have contact lenses. So now I hope I made you a bit curious on how this can be set up, and therefore I jump directly into the code. First, stop sharing this screen and continue sharing the terminal. And don't be scared of the terminal. I won't write a lot of code. Now let's define a Python class. No. Now the only thing you have to do is pip install Jina NOW. And in my case, it's a bit faster because I already installed it. As you can see, requirement already satisfied. And then you do Jina NOW start. And then it's doing a small initialization. And then we'll ask you what case you have currently. And as you have seen before, there was a text to image case and also an image to text case. Also possible, and also the image to image case, like the last one where I also did the photo and then got some images as result. And yeah, so the two follow-up cases, one is music to music search, which I was privileged and could already look into this. Was very fun playing around with to get music recommendation based on your favorite sounds. And then also the text-to-text search Andrea mentioned before. Yeah, what you do is then you select your case. If you would like to have, like Andrea did also for this image search, for fashion search, you would like to have a text-to-image search. Then you can choose a quality. Of course, you would like to have the best possible quality, I'm sure. But when you do local deployment, for instance, take into consideration that like excellent quality, then also indexing will be slower because you have less queries per second for indexing and also for running them for the end user. So we choose in this case local, like medium quality. And then, so this should not come too much as a surprise. You can select one of our example data sets. These I have shown you before, and even more. Like I've shown you, for instance, the NFT, Bored Apes data set, and the fashion data set. And it's also possible to select custom. So when I do custom, then I can choose to use a document array. There's a preferred way because if you know already what Docker array is, then you can push your Docker array to the cloud, and then we can just get it via the ID. course, you can have your Docker array hosted somewhere, or you can just provide a local path of, as I said before, my vacation images. And you define local paths. So this is not a real path, but you get the message basically. And then next thing is you can choose you would like to deploy it locally or running on our cloud. I guess when you have very private data and you don't want to go through all the restrictions in your company to finally get started, you can also just try it out right now by doing the local deployment. And then if all this like NDA is set up and stuff, that's also possible to host it on our cloud infrastructure, which is even for free currently. So use the chance, be one of the people who can still use it for free. All right. That's regarding this demo. Of course, I just put a random local path, so there will not much happen, but I think when you do pip install Jina -now and then Jina NOW start, then you can experience everything on your own and deploy it locally or in the cloud. It will take a bit, so that's why I'm coming back to the Zoom call right now, and I'm curious to hear your questions.
All right, so Florian, we have another question here. So if an image isn't there in the data set, does it generate an image like DALL-E?
No, it doesn't. I mean, it would be possible in theory, but not being there. So like we have to really define what that actually means, because there's never the exact image there I'm searching for. Right? It's always in nearest neighbor with certain distance to the text query. And you could define like, okay, if it's not within that range, then I generate. This, I agree, is like a fun case. We have not seen this in the industry so far, because usually someone who would like to make their data searchable, they really just would like to get their online articles shown to the users and not some fake articles which don't exist because the user cannot buy it anyways. Yeah.
Perfect. All right. And then we have another question that came in earlier. I do believe this one was for Andrea, but the question was, have you tried to create a website layout via AI?
No, I haven't tried the layout. No, I work with text and images, but no layout. Not ready for that yet.
Okay, great. All right. So to our attendees and our viewers, any other questions that you have for Florian? All right. And
I do have one.
Yeah.
So we know that one of the reason why the fine tuner exists is that allows you to revise the weights in a model and therefore kind of refine the results. How far are you from kind of connecting the fine tuner with Now?
Okay, cool. Yes. How much time do we have on the presentation?
We have about 3 more minutes to get through the Q&A. 3 to 5 minutes. I'll give you that.
Okay, then I give my best.
But if you need to go over, it's fine. I have closing remarks after that, and I can fly right through them. So.
Okay. Basically, question with this: why do we have this? Why do you have training at all? The thing is, so we could just use our pre-trained network and apply it to everything. But then for some use cases, the shape of the clothes might be more important. And so this one is the exact same shape as this one, same model, but it has a different color. But for some search or recommendation engine, this might be the top one result in their requirements. And then for other cases, the shape doesn't matter so much. So we just would like to have something of similar color, and that would be that case. And then a third client might not care about the clothes at all, but just about the type of model. So in the past, I worked with model agencies together, for instance. They would like to input one of the actors and then find just similar actors for possible replacement or doubling or something. And therefore, like we always have to fine tune the data for different use cases. And Jina NOW is already doing this. So when you specify the fine tuner label for the documents, then it's taking these documents and putting them together in one class, and during the training process, makes sure they come closer together in the latent space than the dissimilar ones, and depending on each use case. Yeah.
Cool. Yeah, that's good.
All right. It looks like we got another question in here, Florian. Can you provide?
Sorry, one remark. Sorry, I just forgot to say. For instance, the fashion case you have seen, this is a fine-tuned. This is a fine-tuned one, because at the start we had problems that it was caring about skin color, for instance, in the results, or just giving the exact same model, but it didn't care so much about the clothing. And then we fine-tuned it in that described way. And yeah, then now the results, as you have seen, look much better. Okay, sorry for interrupting.
No, you're good. Happy to let you finish the thought. So the next question that we have is just, Florian, could you provide a little more detail of the pipelines that you were discussing before?
Mm-hmm. So the pipelines, did I talk about pipelines?
I think it was in reference to when you were discussing the images, where they came from. And it looks like, yeah.
Okay.
Richard, do you have any clarity on that question? All right, they might not be paying attention right now.
Okay. So yeah, maybe one possible answer to that question is, like, where does the data come from? We currently host it on Google Cloud Storage as document array, the example data sets, but yeah, all the other data sets. Like, maybe the question is also about how to use document array. So it's an open source tool, like library you can use, and you just check out on GitHub Dockarray, and then you can see how to process your data and bring it in the right format to be used for Jina. Right. But yeah, it's not mandatory.
They did clarify their question. So it was when you were showing the search examples, kind of like what was going on in the background. So like, where does it get SpongeBob from?
Where did it get? So it translates the text query into a latent vector, a vector representation. And then it also translates all the images also into vectors. And what it then does is it checks where is a text query in the latent space. And from there, it does a nearest neighbor search and just looks in that area where are there some images also in the same latent space. Yeah. And then it retrieves these as search results. And the closer the image is, the higher ranking it gets.
Great. All right. Any other questions? I believe I got them all, but if I missed one, oh, here we go. We got another one. So what models were used in those pipelines?
We used the CLIP model and then trained a linear head on top. So we just used CLIP model for inference as it is without fine-tuning it, getting the vector representation out of this. And these representations contain basically the very dense knowledge about everything you can describe in this image. And then from there, we just fine-tuned one linear head, just one layer. It's basically about forgetting more about like compressing some of these dimensions to learn what not to take care of. For instance, not ignore the skin color, ignore the age of the person or something. And it fits actually very well also to what Andrea mentioned before, like how we can reduce the bias by fine-tuning, for instance. Having a bias-free data set.
Perfect.
Is it now, I mean, how do you see it now within the kind of the ecosystem that Jina is building? Is it, you know, the way to kickstart things, or what is the ambition of now within the ecosystem?
Yes. So for the most common use cases we discover, we create this Now app, which then like is very optimized for this very specific use case. Like you can think of with so many different possible modalities. And then from all these modalities, I just have to quickly share my screen because I think it's much better to describe it that way. So we have all these modalities and all these possible searches we could do, like from image to some text data, or to 3D objects, or from movie to sound. And this basically explodes with every all these new modalities joining. And what we do is we still let, with our framework, you could build all of these. You could optimize the search case for all of these different searches. But for the most common, we make sure we build a solution which works for all users facing that issue. And then without doing any extra manual work. And therefore, quick shout out to, or like request to everyone, if you think like your use case is not covered, you have something with audio or with movies or something, and you have not seen it here, please let us know. Like this, the more votes we get on these edges, basically, the higher it comes in priority, and then we will implement it and make it work.
Yes, and feeding off of that, what Florian said, I did drop the link to our Slack community in here. So any questions that anyone thinks of after Engineering All Hands has ended, you're welcome to join the Slack community and kind of drop your questions in there. And as Florian mentioned, please, 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 like, we want feedback. Let us know. Is there something that, you know, you want to hear more about in the next Engineering All Hands? Is there another topic you want to discuss? Do you want to present a topic? Let us know in that Slack channel as well. And then, you know, if there's something that you don't feel we are covering and you have a specific use case, please reach out. We're more than happy to work with you there. And then I've got a few quick event announcements while we're wrapping up here for all of our Berlin viewers. On June 15th, we have an in-person event with Pi Data Berlin. That starts at 1900 CET. We also have in Berlin, June 22nd through the 24th, we will have a presence at the Data Lift Summit. Max Work will be presenting. For our Paris viewers, starting tomorrow through Saturday, June 18th, we will have a booth. The booth number is C033. Come by and say hello, maybe get some swag. And for our US viewers, our COO Bing is presenting at the Open Source Summit in North America in Austin, Texas at the JW Marriott, the 23rd of June. And with that said, we highly, highly encourage you all to go try out Jina Now. Please give us some feedback. Lisa, our colleague, has dropped the link to Jina Now in there. So give it a try and let us know what you think. Thank you. Great, Sherry. I dropped in the event information again as well in our chat. And thank you everyone for your time. Thank you, Andrea. Again, that was an awesome presentation, and Florian for breaking down Jina Now for us. Much appreciated.
Ciao.
Everyone.
Thanks for hosting. Bye-bye.
Bye-bye.